Yeah, the road, good. Everyone awake this morning?
Yeah.
Well, yeah, good, yeah. All right, did y'all run yesterday?
I think.
Okay. All right, well, good. So real quick, we'll do a couple of, rules and then we'll do a few introductions and then we'll let y'all get started. First off, this is y'all's opportunity, just to let y'all know, this is your opportunity to kick anybody out if you want to in the room, just to let you know. But we just go with, make sure this is all about you guys. And so if we see any distraction from you guys, we roll that up. And if you're videoing, it's fine, but just want to let you know too, we don't go back and replay and check grades or anything like that.
Oh, no, never.
And I know that's not your reason,
Yeah.
but we just have to make that mention. But again, like I said, if y'all are uncomfortable, this is y'all's time to give me a wink, and I can kick them out, it'd be nice, But I think we're all good. And then so other rules, and I'm sure y'all are aware of this, of course, you have 15 minutes to do a presentation, right? And then after that, we'll start off with about 10-minute Q&A basically. Hamid will give you a countdown, he'll get y'all started here in a minute, and then he'll give you a 5-minute and 2-minute, just a heads up kind of thing, just to let you know. Best thing is to try to keep that 15 minutes as best you can. I'm sure this is not the first time you've practiced this, so I'm sure y'all probably know down to the minute how long y'all have it. But if you go over a little bit, it's okay, but keep in mind that goes into the questions and stuff like that. So first off, my name is Pat Barrow. I work for Oceaneering. I've been with Oceaneering for next year will be 30 years. I have supported this competition for 22 years. And I tell this to every team too. I learn stuff every year that I come here. And I work in the new product development group of Oceaneering, so I get to see the upfront new stuff that's right up going on. So that's really saying a lot about what you guys do, and so it's exciting for me, and educational for me every time I come up here to see stuff. So it's really wonderful. It's really neat thing to see. A little bit about my background. I started off in aviation, so I have a little bit of a heart for what y'all are gonna do. So I worked in as a technician for many years. I'm a pilot. I've done some aerobatics and all kinds of stuff. But then went back to school in my late 20s, got an engineering degree, worked and then started off with Oceaneering, worked in the space industry, worked at the Neutral Buoyancy Laboratory for 15 years, operation manager, maintenance, engineering director, etc. Stuff like that. Got into oil and gas, and then into Oceaneering also, and then I'm now project manager, as I said, into the new product development. So I've kind of combined all of those things together, and I say all that to tell you all this, that everything that y'all do makes you who you are, right? All those experiences are good to do. The neat thing about this competition, I'm sure y'all realize, is you kind of get a little bit of flavor of everything. You design, you get your hands dirty, put things together, you analyze, you do all those things, and all that's good stuff to do. But that's enough about me. I'm going to let the rest of folks introduce themselves.
Tom Oliveira, I'm a senior chief robotics engineer. Bounced around a lot of different industries, but typically only at a couple different companies. Started at main competition. I competed the first 2 years of competition. The first year was miserable. We were one of the few classes that did dynamic ballast, and we didn't come back off the bottom after we got there. We never tested at real depths before we showed up, so a lot of lessons learned. The second year we went back and won the Explorer class, so it was pretty exciting. A lot of great stuff comes out of this competition. Like Pat mentioned, right, you're picking up stuff from a lot of different aspects. You're looking at business, you're looking at different industry tie-ins and academic tie-ins that you wouldn't have gotten without doing something like this. So I went through satellite deployment system and development, worked underwater robotics, did rover development for the NASA group at Johnson Space Center, and now I work for Pratt Miller, which is half motorsports like Corvette Racing Le Mans, and the other half is defense robotics.
I'm professor of engineering from Arab Academy for Science Technology, Backend Transport in Egypt, specialized in the marine and heavy dynamics and ROV as well. And I have a background of ROV like 15 years ago now, as a doctoring and also as a mentor. Maybe like 10
Mark Thompson. I'm the company's CEO.
I'm Braden Ballard, the electrical lead.
I'm Gabby Angeno, the props propagation specialist.
I'm Robert Thibodeau, the mechanical lead.
I'm Nicholas Chamberlain, CFO.
I'm Justin Yoakum, the safety officer.
And I'm Jack McSwiggan, the pilot.
So we are Team Waveco. We are a fully student-led organization of 13 members, although we only have 7 members with us today. Before we get started, I'd like to acknowledge a few of our mentors and sponsors. First and foremost, Seth LaCour and Dennis Courtney. They've provided their wealth of knowledge and experience to us, and that has been instrumental in getting us here today. We also have Tim Maskell. He has helped us out significantly with travel and logistics and spent many late nights getting us all the equipment we need. Daniel G. Penny III, he has helped us out with getting our hotel. He has paid for our hotels and made sure that we are all ready to go and all that stuff. So I'd like to thank VectorNav and Vol Servos for donating multiple pieces of equipment that have been really beneficial to us. And Juan Rodriguez for purchasing our equipment, and Mate for giving us the opportunity to compete. Of course, before we really get into the presentation, I think we should talk about safety.
Yeah, so obviously, before we put anything in the water, we have to make sure it's safe, or else what's the point of all this? So, one of the main things that we wanted to do was, since during our pool tests, we usually have a safety diver to keep an eye on it, make sure everything's going okay. So, we have like the thruster guards, all of that, but we also have rules in place for that diver, all of the people on the pool deck. For example, always wear closed-toed shoes with at least ample amount of grip, prevent people falling in, all of that fun stuff. So, we also require that all hair longer than shoulder length be tied up. Thrusters spin, thrusters suck, bad day. What else? Yeah, whenever we're working with the electronics tube, we ideally do it with all power cut to the sub, but in the rare instances where we need to have the power on, we wear electrically insulated gloves, prevent any, not only damage to us, but damage to equipment because of shorting, all that.
So before we even get started talking about the ROV, let's go over our design goals. One of the main things we wanted to produce was a highly modular ROV and a highly serviceable ROV, as well as being something highly marketable. So with our modularity, we wanted to get a 1-inch aluminum T-slot extrusion frame so we can mount things to it very effectively. We also have an electronics tray that slides out. You'll see that later, allow us to service the ROV very effectively. And the marketability is that we intended with this to be a platform for companies to come into us and say, hey, we need to do X things. We have this tooling that we've already made for it. Give us a sub that's already integrated with all of that, and then we need it in 2 weeks. So we have a short lead time, we have something that can be highly configured very quickly, anywhere from running off of a Raspberry Pi or a full desktop class computer. So yeah, and talk about some other things. Yeah.
So, after last year's competition, we had a really big decision to make, and it was whether we were going to start from scratch or keep the same build. And we decided to put our money where our mouth is and keep the same build. As you can see, we're going to talk about modularity a lot today. We have appendages pretty much attached everywhere. Those can be moved anywhere that we need it to be. We decided to, instead of rebuild, make upgrades. So angle brackets have been reprinted. We've reprinted the thruster mounts, and we've also added tools, as you will hear a lot more about later. We've made changes to the strain relief, and we've also made just general upgrades all around the sub, as opposed to completely trashing it. We decided to just work with what we had and just building on that and what we had from before.
Yeah. So for a general mechanical overview, our sub, as you can say, as Mark said, is built around this 1-inch T-slot aluminum, which is kind of just our, our bread and butter. Everything we have sticks into, aluminum with a T-nut at the end, and it can be moved around in everything. So we decided to go with a general exoskeleton, which a lot of teams kind of have. A lot of teams have a lot of their tools more outside and a lot of stuff outside, whereas ours is a lot bigger than a lot of subs because we have our big exoskeleton here. This is to prevent any sort of damage to thrusters or anything, because, obviously damaging a thruster can be really impactful to your run. In our case though, we have our 8 thrusters, 4 vertical and 4 horizontal that provides a full 6 degrees of freedom in translational, sway, pitch, roll, yaw, all of the sorts. But something that's special with our configuration is that in almost every case, if any individual thruster dies, we have redundancy that can keep us going forward. Like last year, a problem that we ran into was one of our thrusters died almost right before competition, and we were able to fix the thruster layout and mapping to make us still have our full 6 degrees of freedom. Another thing that helps a lot is this electronics tray right here. This electronics tray this electronics tube is where we house everything that needs to be cut off from the dangers of the water, like electronics, and we have, our main computer and everything. So this can be actually, when we take off our bulkhead right here, we designed it so that the electronics can be fully removed. And they slide out kind of like a book. Yeah, that's a bit of a general overview of our mechanical stuff. So,
As far as electrical stuff goes, we are taking in 48 volt 30 amp through the terminals here, and that is being stepped down to 24 volt for our thrusters. We did flirt with 48 volt for the thrusters, but that was a little too much. And then from there, it's being set down to 12 volt for our Latte Panda and our other supporting electronics. And then for everything that requires 5 volt, we're just taking the signals off of the Panda to get that power.
Yeah, so for software-wise, our entire system is ROS2 humble. It's mainly C++ scripting with Python launch files. We do this so that we can maintain a very highly modular system that allows us to make changes on the fly. Like the thrusters mentioned, we don't have to turn off the sub to go from one thruster failure being catastrophic to not being a problem at all. It also allows us to easily, since ROS2 Humble is more of a modular system, it allows customers to very easily integrate their own individual software packages into our systems. And one of our things this year was a lot of flight controls, and that was improved significantly.
Yeah, so our control setup is unconventional compared to most teams. Most teams tend to use some sort of game controller. Ours is primarily for flight simulator. We're using the Lenovo X56 Rhino HOTAS setup, where we have a pretty big throttle piece here with lots of buttons, and then we have a joystick that not only acts as a normal joystick, but can rotate and has additional functionality there. That allows me to have a lot of control over various sorts of tooling, and not to mention I have very good control over maneuverability. So typically what we have, moving a joystick like this results in translation, this results in yaw. And to control depth, we actually use this little knob over here. Our sub has PIDs, which means that really, instead of just adding or subtracting power by moving the throttle up and down, we can set a set point using this knob, and that allows us to hold our current depth. On the screen, typically what we have is 2 camera feeds here, because we have our center camera and our side camera. Having 2 of those allows us to have depth perception. It also allows us to see around the sub where one camera could not. One issue in particular was having this hook. We couldn't see if, we could see that it's near an object, but sometimes it's slightly off, so that's very helpful. More importantly, we're able to see the net, which is very crucial for this year's task. On the screen, there will be 2 cameras, and then over here will be various printouts of some of the PID outputs and sub's orientation. And that's essentially an overview of the basics of the sub. We're going to get more sort of tool specific, and what I'm actually going to do is, if you want, I have this sheet, which is our test plan. So that is essentially the order that we're going to go through our tasks during an average run. There have been slight modifications, but those aren't particularly important at this point. What you'll see is 4 different runs. That's primarily having to do with either a different camera position or a major sort of prop that we have to come up and recover from the sub. But what I'm going to do is I'm going to go through the major sort of tasks, and we're going to discuss the primary tooling. I believe, let's see. Yes, so the first one we're going to discuss is essentially camera movement. During the run, like I mentioned, sometimes you want to see the hook, and sometimes you want to see the net. Recently, we've developed a new sort of rotating hinge system. Right now, this is not the finalized version, as you can see with the zip ties. We're currently working on printing out sort of improved reinforced version.
It broke off in the car yesterday, right before our run.
But essentially, this means that, you know, when we come up, we can quickly adjust the camera to see any necessary aspects of a given task.
Okay, so next, we have the sample collection. So, one of the big things this year is water purity, how we measure that, all that. So, to do that, we have a submersible 12-volt water pump, and using one of the switches on the HOTAS, we're able to power up. It obtains the water, sends it through this hose, fills up the syringe. Once we're on the shore, we just push the syringe, comes back out, push the syringe, comes out the needle attachment.
And the next task we have is the hydrophone. That one we use the hook for, which allows us to maintain a more simple, straightforward gripping mechanism. No extra points of failure like you would get with a mechanically or electrically actuated gripper. One of the things that was extremely important for that task is maintaining highly accurate depth control with our BID control system. We use a bar 30 depth sensor for that, and that allows us to maintain a depth within plus or minus about 5 centimeters at the set point.
Another one of the big tasks is collecting the little polyps off the side of the solar array. And for that, obviously, one of the obvious methods is to use a hook of sorts. So we have hooks so we can come from the side or straight on. But also, the pipe cleaners do have a steel wire running through them, so we have a magnet. So once we get any slight hook on it, it'll attach to the magnet and it'll be affixed there, and we won't have any issues with it floating away from the sun.
When it came to our fish aggregate, we realized that our original design really wasn't ideal as we planned. So we were in the hotel room about 2 days ago, and we were eating out of this orange bag, and we realized, hey, or actually Justin was like, hey guys, why don't we actually just take this net from the orange bag and reuse it in our sub? So it basically came to me creating these kind of mounting brackets here. And what it is a snap fit, so that way the orange net goes in between them and they press together and it holds it. For that, we really like this idea because we figured that we were taking into account how much like pollution and things that happen, especially here in the Great Lakes. You have a lot of mining and a lot of like plastic pollution. So we decided to take that and sort of reuse the idea, and I actually really like it a lot.
The next task was the anode. This is one that benefits greatly from having an actual mechanically operated gripper. This is not our original design. We had all of our attempts at waterproofing servos fail on us. We currently have one servo half disassembled and a cup of mineral oil. So this is our new design. This is one of our thrusters disassembled and then put into a 1379:1 gear ratio box, which is being connected to our original gripper design, and that allows us to have a lot of power behind it, and it makes it a lot easier to keep it waterproof since there's nothing that can actually get ruined.
And on that note, one of the most important things we just figured out this year is that having as much pool time as possible is very important. And one of the things we wanted to improve was our thrusters. We want to make them more efficient. So we attempted running 48 volts directly to the T200 beyond their rated range. We did this with we wanted to verify that this was actually safe and good for the thrusters. So we did a 24-hour burn test running the thrusters consistently in a test tank. And we did determine that they would survive just fine. However, they weren't as efficient, and we determined that the cost difference between extra simplicity and efficiency was not worth it.
With our pool testing, we do it every Saturday. We actually have a checklist that we use every single time. We never leave the lab without checking the list and going down everything, because obviously we think that consistency is super important. No matter how many times you do something, you should always make sure you're doing it right. So we get to the pool, we have an idea of what we want to cover for that day, and then we have scribes taking notes the whole time if anything goes wrong or if something doesn't turn out the way we planned. We immediately return back to the lab after we finish pool testing for the day, we go over what we missed, and then we plan for the next one.
Alrighty, so we had a few major hurdles this year when it came to pool testing. One of the main ones was our PID control system. It turns out to be extremely complicated, and we ran into some difficulties with our overall ROV design. We focused a lot on maneuverability, so With that, we had our center of buoyancy and center of gravity very close to each other, so we could rotate the sub in all 6 degrees of freedom very easily. And one thing that we noticed is that PID control system requires a already statically stable ROV instead of a neutrally stable. 2 minutes, guys.
No, that's cut off.
Oh, it's cut off, okay. Alright.
Go ahead.
Go ahead.
Yeah, so what we did to remedy that was we added ballast to the bottom of the ROV and buoyancy to the top of the ROV to increase our to raise our center of buoyancy and lower our center of gravity, which when the sub is off perfect neutral axis like this, it increases the riding moment based on the fact that we have a larger vertical distance between the 2 centers.
Yeah, thank you guys for your time.
All right, good job. Well, it sounds like y'all done a lot of work, a lot of, appreciate, well, I like the bag thing. It's amazing
We
that,
like it too.
sometimes the most elegant designs come out of just, hey,
Yeah, it actually works very well.
really nice. Very nice. Well, a lot of good things I see, looks like y'all are planning stuff, I like the idea of, having your, planning for your, I haven't seen this too much, that's good. The one thing I had a question about on safety, same thing though, I was wondering now, what do you do, without giving out what I'm trying to get to, but, safety wise, what could you implement, or what do you implement to make sure every time you're doing the same kind of safety events?
Yeah, so we have people dedicated to different jobs. So when we're doing our full run, we have somebody making sure that the tether isn't a tripping hazard, making sure that's always properly tight. We always make sure that if there's anybody else in the water just using the pool that day, we warn them like, hey, we'll be operating in this radius, just to let you know there's not a shocking hazard, but just to let you know there's a heavy object moving through the water. When we're doing our pre-run checks where we test all the thrusters are moving, make sure nobody's touching them, it's just a visual inspection, we're not checking to make, okay, yeah, that one's vibrating. So we have all these plans in check, or all of these plans ready, so we're never in any danger while we're turning on, operating, or stowing the vehicle.
Yeah, and along with our pool test checklist that really dictates our operations side, we also have a safety checklist that we follow that dictates our personnel side. And we have many bullet points that go over like lifting safety and stuff like that.
I'd also like to mention, as the pilot, whenever I'm maneuvering in the pool, I'll try to clearly communicate to the divers, this is the movement I'm gonna do, watch out, so we do have a hook on the front, we try our best to make that not sharp, but obviously it's still a hook in the water, so we communicate, just try not to be in the front when I'm moving, how to lift.
If we at the same time, aviation, you said something, they said something about you, some of the big answer.
How do you make the adjustment of the balance with RV and the balance affected with the vertical?
I'll take it. Alright, so our goal was to create a neutrally stable, or a neutrally buoyant ROV in the first place. We don't have it, we have the tether, so in case the ROV does find its way at the bottom, we can just pull it back up. The main thing that we do to control our depth is with the thrusters. We take in input data from our barometric pressure sensor, and with the PID control, we vary the output to the thrusters in order to maintain said depth. We do have issues there's one thing with our 6 degrees of freedom, our goal with being able to rotate the sub in all 6 axes, the increase in stability makes that a fair bit harder, and we have to give a lot more overall effort capability to our different rotational axis motors in order to get to the orientation we're looking for. One of the main things with that is we actually want to try and get our sub pitch 90 degrees down, and that is particularly difficult. However, we in-house wrote, along with our PID script, we also wrote a transformer script which uses the IMU we take the quaternion input data from that and do a rotation based on our input velocities that we're looking for in the translational axes, and turn those into what actually needs to happen, because with the vertical thrusters, where our depth hold is in the, is dependent on the axis of thrust is dependent on the orientation of the ROV. Well, the depth control is dependent on not that. So we need to ensure that what we do is we take a rotation with the quaternion about those velocities in order to remap our vertical thrusters to other thrusters, or to horizontal thrusters. So if we're pitched 90 degrees down, the depth hold is completely handled by our horizontal thrusters.
So, did you conduct any test if you have something like one or two of the thrusters shut down during your missions?
We haven't done something like that.
I can say we haven't necessarily done tests on the side, but we have done it in real world scenarios. When we were doing our runs last year, we did have dead thruster, and that it changed throughout the competition as we continuously tried some of our ESCs. So we're losing motors over time, but ultimately, our ability to quickly customize our motor mapping allowed us to actually do, we came about middle of the pack last year, and I think that's pretty good considering all the hardships with that.
Yeah, with Ross 2 Humble, we made sure that all of our thrust vectors are parameters. So we haven't implemented this yet, but in theory, we could have like a layout of buttons like, hey, this thruster's failed. And so as script goes through, it automatically maps all the thrusters within a second.
Sometimes tests aren't planned.
Yeah.
But it's key to be able to take advantage of those situations and collect that data for you guys.
Because sometimes it hasn't actually, yes. During the mission, one of the thrusters it's shut down. So it's like, yes, to have video assist conduct the radio system. Or if I have something like that, I need to move. It will be depending on the bike actually. Yes. And to move the ROV, well, the three thrusters. Yeah.
I was gonna ask you if you guys had a method or a system you use for data collection and how you look through that to do diagnostics.
Well, one of the things we do during every single pool test is we have a scribe. So if the pilot has noticed something, or if the test director notices something.
This upcoming year, I am like the secretary. I think scribe is a very important role because a lot of the time, pool testing can be very chaotic. So it's really important that if Jack sees something or if Mark sees something, someone is there just to write it down immediately. I don't have it on me, but I do carry a little notebook around, and I do carry it at pool testing. And so does our other scribe, Garrett, who's not here at the moment, but and B does as well. We all have this little notebooks that we take notes down. Like if Mark shouts out a number, I'm like, okay, you write that down. So.
Also, since we're using ROS 2, what we can do is Jack can continue to pilot with all of his camera views and all that, and then Mark can remote in with his laptop and say one of the PIDs is acting a bit weird. He can see the whole PID graph, what the effort's doing, all of that, so that we can see the data, but also keep on running the stuff at the same time.
What was your biggest challenge?
Yes.
I'll talk about something that I had mentioned earlier. We definitely faced a budget cut this year. Last year, we spent probably 10 times as much as we did this year. And obviously our club AMRA is split between two projects. It's this and RoboSub. And so the money that we're getting funding from the school doesn't all go to one club, so it is split. But we were able to overcome that obviously by keeping the same sub. So not having to spend as much on the frame, the electronics and everything.
Yeah, so we can talk about the gripper iterations
Yes.
too.
So all of this year, we've been working to develop some sort of gripper. This one didn't get actually any of it designed until 2 nights ago. Luckily, we brought a 3D printer with us, so we were able to get most of it down. After this, we're actually going to install it on the sub when we have some time. So one of the first ideas that we had was to make a clamshell that could go over one of the servos, as Rob showing you there. That was actually machined in-house with Mark owns a small CNC mill. So we designed it, fabricated it all in-house, still dealing with a bit of leakage. So,
With all the sealant that you can see added everywhere.
yeah, so we also had Bulls, which donated a few of their DA-22 sub servos, which are, they claim to be rated down to 100 meters. However, during our testing, we had a few go out. We found out that through the output shaft, it's actually a through hole. So nowhere in the documentation did it say that that needed to be sealed or anything, so we were just getting water straight through into the servo.
We finally thought we had a way that we fully sealed it, like almost like about a few days before we left for comp. And we had done a test and it hadn't, leaked or anything and it was working. And then we get here, 2 days ago and we're in the pool and it just decides that it's,
That never
it's done.
happens really, I don't know what you're talking about.
And it was,
Always
done.
smells at the last minute, you're not sure.
so that's when we're able to switch over to the T-Trundle thruster.
You talking about finances and stuff like that, so do y'all plan a budget at the beginning of the year? Do you have something that you estimate your costs and like to?
That's the hard part, because of how our school operates, it's more, we request equipment at the beginning of each semester. So if we come across anything in the middle of the semester that we find out we need, it's always a struggle to find funding for that, or do we have to wait until the next semester to get it? And sometimes that completely throws off our entire plan.
Yeah. We normally try and have estimated allotments for travel or for, tooling or for consumable stuff. And normally we try and estimate a little over for travel and stuff like that, but it can sometimes be, depending on things failing, like servos and stuff, it can be a little
Can
unreliable.
you define your risk initially at the beginning of a semester, like what do I know, what are the things that I'm not 100% sure about, or things that I don't know as much about that has a risk, and you can tie a dollar amount to it. And then as you come to that risk, you can retire, you can use the money for something else, or you give it back. I'm just telling you things that you do in the industry. Research and development is what you're doing is very difficult to capture a dollar amount, but it doesn't matter. Your boss doesn't care. Your boss wants to know how much you're gonna spend at the end of the year. I don't care how much it is, you don't go over it. But, and that doesn't mean you fluff the money or you just say, I've got a bunch of contingency over here. You have to identify those risks and the best you can, right? One risk might be, I know I'm gonna have to deal with this design over here. It's completely new. There's an opportunity for additional tools for it. I'm estimating those tools at this much, blah, 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 whatever. And so, I didn't know, that's just something to think about.
Very good.
Yeah. Just something.
I think another thing with the budget that can help us stay under is a lot of our stuff is manufactured in-house, so we don't have to set a certain amount. Obviously everything's much more expensive to buy
How
from
much
somewhere.
does that be?
For what?
That would be how much does
It's approximately 12,500 now, I believe. Last year it was about 10,000, so we really didn't add that much more value to it this year.
And then that's including all the supporting ground equipment, like the Toughbook laptop, the HOTAS.
Yeah, and
Our
estimate-
power state or ground power station.
Yeah, and the estimated value of all the donations in terms of the whole servo and our vector nav IMU.
So what about the used component that is used for the used for all the food?
Yeah, we,
For the application that we used the last year.
Oh,
yep.
So one of the main reasons we used a large quantity of our components is that with our software package and all of that, it took a long time to get it developed properly. So we weren't at the limit of what our systems could do. We were at the limit of what we were doing with our systems. So what we learned is that we didn't have any hardware issues or things that we could do, we could buy better tooling for. And if we did, we focused on getting stuff like that. So we spent $750 in R&D this year. That was our main focus, was improving, doing thruster testing and see if we can add simplicity to a system, or with one of our biggest hurdles, which was the gripper. That was our main focus. We determined that we'd much better off to expand and grow more into the systems that we have, rather than buying a whole new system that would require us to rework our truly not really perfectly mature design in the first place.
I would also like to mention is, the club sort of research director, is that we designed a sub not necessarily just for the competition. So it's much larger, allowing us to have extra tooling. One thing our club is hoping to eventually get into is sort of professional research. On the back, even though it's not wired up, we do have a one-dimensional sonar. Some of our other club members who are more software proficient are actually doing their own research on basically doing data scanning and basically analysis for 360 sonar. So having just really our pre-existent frame pretty much ready to go whenever allows us to adapt to sort of shifting projects that we have in the club.
Yeah, and that was something that we actually did do this year. We were on a research poster presented by some of our members, and our sub allowed them to get the data that they needed to test their filtering algorithms.
Yeah. How many of your team is returning? Returned from previous years?
A fair few.
Yeah, of us, 7.
5.
Yeah.
7 of us here, 5 are returning.
And then
Then a lot of our new members weren't able to make it this year.
Feel free to touch whatever you want.
It's designed.
It's.
I'll say
Mark,
that.
you can take your thing on our
Oh, yeah.
podcast.
Yeah. So you
That's
wanna
the
see
statement,
that?
that's in the statement
No,
that you
I
gave
see.
Yeah.
We put the zip ties there because we found that when we were in the pool sometimes, when the ping pong balls would come in here, this would float up and like fold around. So we actually put the zip ties in place to like that. But it's actually nice because it's still self-sealing because the ping pong balls just float right here rather than going forward.
Yeah, it allows us to do that task and then to go do other tasks that require us to bring stuff back up to the surface.
Yeah, we actually don't have the map thing on right now, but this piece slides off. Sometimes not very good. We have another mount that we actually are we're reprinting to put on now, but it can slide on, and we're gonna slide it on right here for the Medusa task. It can go up and just like hang like a little net. And
Yeah, it's kind of funny that the simplest things sometimes are your best thing. I can give you an
I
example.
like how excited you guys are.
Yeah, yeah.
I love it.
Yeah, we're very happy with it.
I can give you an example. Tom probably recognizes it, but when I worked with NASA and stuff, they try to like complicate things very much, right? And so I think the thing was we need a writing utensil in space that the gravity doesn't affect issues. We have ink, all this kind of stuff. Billions of dollars later, the Russians said, "Why don't you just use a pencil tool?"
Yeah.
I mean, so same thing. This worked much better. Yeah. Simpler, simpler.
had to leave all the orange
Yes,
stuff on, just because
Yeah, that's nice.
a little bit of decoration and aesthetics.
Because so many people like walk up, they're like,
Yep.
is that an orange back? I'm like, yeah.
Sure.
Yeah, we were really trying to like think out of the box with this ROV. Like we have our whole. Let's go pull up pictures of the thing we were doing. So like we have to measure the shipwreck wreck, we just put a measuring tape on our tether, and also marked out zip ties that are known colors, which are a known distance away, just to indicate that, so the pilot can see a little easier. And one thing we came up with in the hotel room was, well, we needed a way to test our float, and
The bathtub's only like this tall.
our float kind of sits like this in the water.
Yeah, our float is
So
pretty
Yeah.
we noticed that in one of the other hotel rooms we had, there was a table that had a completely hollow bottom. So we took that table, flipped it upside down, and then got some trash bags, and then filled it with water, and then we could test our float.
If you're not building a hotel, you're not building.
Yeah.
Yeah, so we made our own little pool about that tall. Yeah, worked pretty well.
And it was free.
We're on the second floor and third floor.
Second floor, but the lobby's
But we're over the
below.
lobby, so.
Okay.
Exactly,
Yeah,
yeah.
we made a lot of noise and stayed up a little bit too late working on
The
this.
whole team's made that.
Yeah.
A lot of noisy and excited about it.
Yeah.
Obviously, that wasn't our first choice, but the hotel pool has been closed, so
Oh.
that hampered our development a bit.
And if we're wanting to test at, 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m.,
Yeah.
it's easy to have it right there. There's not that one that's had a lot of water in it.
Yeah.
Alright, guys. It looks good. Looks good. Yeah. Nice. Good luck, guys.
Thank you.